Energy resource notes. I've got my screen over here trying to record so that the notes we're going to use, we're going to start where it says, so I can zoom out for just a second. Oh, back over here. So we're going to start where it says energy sources, our two little triangles. I've already filled this in just so you can see where we're going. And then the energy sources on the back with the little turbine. Then we're going to go to the second page and talk about the renewable energies, non-renewable versus renewable, and end off with 5 alternatives or renewable energies. So first things first, you are going to need a pen and probably a couple colors. I'm going to try to go as quick as possible but not lose anybody. So we're going to start again, starting where it says energy resources or energy sources. So this PowerPoint is pulled from one done by Science Doodles. That's where I pulled all the pictures from. So our vocabulary words that we're going to look at are renewable, non-renewable, fossil fuels, coal, petroleum, natural gas, nuclear power, biomass, wind energy, hydropower, geothermal, solar, energy pollution, landfill, greenhouse gases, recycling, conservation. So these are all the words you can pull from if you are trying to do vocabulary for this week. Then we get into what is a renewable resource. So a renewable resource is going to be one that the energy is replaceable by natural means within a human's lifetime. So our 5 that we're going to start with are going to be these 5 right here. So I'm going to do just like the little triangle on the picture says, wind, solar, hydropower, geothermal, biomass. And I'm going to put a little 5 over here because there's 5 of them that we're going to look at. So our first that we're going to look at is we're going to try to define what is a renewable resource. So on the inside, you have this little kind of sort of panel. It's not really a triangle, but it kind of looks like a triangle. Just a little bit. So we're going to fill that in. It's basically what's here on the board. I just kind of rewrote it to make it a little more streamlined. So renewable, there's 5 of them, so put a little 5 there. These are things that we can replace. I can use them multiple times. They're naturally occurring, so it's not something that people have to make. And then typically they're in nature in some form or fashion. So our first one is going to be our wind. So with the wind turbine, and they've been in the news a little bit today, or the last couple days, with the ice storms. So the wind turbines, so these turbines, the wind pushes the blades. So the blades are angular, they're not straight and flat. They have a little bit of a curvature to them. So when the wind hits it, it starts to push it like a windmill. As it pushes it like a windmill, it stores power up in these batteries in the back that sends electricity down through wires underneath the ground. The wires under the ground push the power to the city or the state around it. The hydropower have same kind of turbines, but now it's water that's going to push them. And it pushes what's called a wheel inside of a dam or as a part of a dam. And then as the wheel turns, pushes electricity, stores it in a kind of a battery like this one that distributes it to the city or the state around it. Solar power, powered by the sun. There are these solar panels. You can see them on the sides of houses, some on buildings. If you've ever been to IKEA, they're all over the top of IKEA. So the solar panels have these cells that are kind of square shaped. And when the cells, they have little carbons in them. And when the carbon gets excited, because it's getting heated up, it moves around. As it moves around, electricity is discharged. The electricity is then fed back into the city, or the state, or the house, and used as energy. Geothermal is heat from inside of the earth. And I wrote volcano over there. And then the last one is biomass. So it's organic materials that are burned. We don't use this very much in the US, but it can also be used as a gasoline. So they take organic materials that are left over, such as plants and then animal waste, and they burn it to create a gasoline. So we get into our pictures. There's nothing to write here. We're just kind of reviewing what we just said. So biomass, corn is the biggest one, but animal waste like cow poop is collected and burned, and then the heat and the liquids that are left over from it are used as a gasoline. Wind energy, our turbines, harness electricity by the spinning of their blades. Hydropower, again, we have those big dams. So I use my cursor. There's panels, the little wheels are behind these little parts that look like a waterfall. And as the water that's collected by the lake rushes through, it pushes those wheels and turns them, and then it stores the battery. It's over here. So there is a dam at Lake Louisville, and we do have a hydropower over at Lake Louisville. Then we get geothermal, the heat that is escaping from the vents within inside of the Earth's surface comes through kind of like a panel or a wheel that's located underneath as the wheel turns from the gas escaping. Then it stores it up into a battery and again sends it off. So we get into our non-renewables. Get into our non-renewables now. I'm going to change my pen color. So our non-renewable energies are resources that I can't use again and again. It's usually a one-time and a done. And then on top of that, it takes millions of years to form. So our 4 non-renewable energies are nuclear, oil, coal, natural gas. I'm missing one. Nuclear, oil, coal, natural gas. Nope, that's 4. So I did a little 4 up here on the top. So I'm going to leave those there for just a second. So our non-renewable resources, so inside, up at the top, I'm going to write runs out, exclamation point, because these are eventually going to run out. And then I'm going to write down what they are beside them. So renewable energy is energy that is not easily replaced. It is a one and done. And then my coal is black. It's a solid. It's a black solid, and it's from ancient swamp plants. And then I get our oil formed from ancient marine life. Our natural gas formed from ancient marine life again. And then nuclear. It's from the energy from splitting atoms. So we're going to get into this, guys. So on my paper, I used a green marker and I underlined coal, oil, and natural gas because those are my fossil fuels. So they are from living organisms. So fossil fuels, they're from the formation of long time ago dead things. And I get coal, natural gas, and oil. So if I start with coal, you don't have to write anything down. We're just going to kind of talk about it real quick. So it's a hard black solid. If you look at it, it looks quite dirty. And this is from millions of years ago. The plants that were in oceans or lakes that have since dried up and died. And then been compaction and cementation, like rock cycle, had the formation of coal. Oil or petroleum. So petroleum products, these things here, petroleum products, make a lot of plastics. So without knowing it, all of our oil production has a lot of plastics that we use. And with those plastics, we get a lot of excess pollution. But liquid, it's kind of a yellow or a black liquid. Lots of hydrocarbons that are in it, or hydrogen and carbon. And they are from the decaying things from ancient marine life. Natural gas, we cook with this one. So on my paper I wrote, we cook with it, cook with it. It's used to cook with. It's found above where the oil is. So if we're looking in layers, right? Layers. So our natural gas would be here, and then our oil would be just below it. And then we get our nuclear power. So our nuclear power comes from uranium and plutonium products that are split. So they take uranium and plutonium atoms, they split it, get that big explosion. With that explosion, it's more of a steam that's released and a gas that's released. So our solar resources, should have been up there with the other one. So I'm going to move it for you guys to look at when you go to look at it. So our solar panels, again, it's that energy that's moved around. The panels have carbon in the black parts, and as it gets activated and gets excited, it moves around, it wiggles, causes electricity to create a current. That current is routed back to the house. So then the good, the bad, and the ugly. So my paper has the very simplified versions of it. So coal, oil, natural gas, and nuclear. So with coal, there's more hydrocarbons that are involved with it. So it's considered simpler to break down. It's twice the energy of wood. So if I got 6 pounds of coal and 6 pounds of wood, the coal is gonna have more energy to release in it. It's cost-effective plants, meaning the amount of energy, the amount of money that I put in to get the coal out is how much energy and money I get when I sell the coal product away. The bad parts. It's one of the leading causes for global warming, and the mines are destructive to the environment, so they have to dig these big holes in the ground to get the coal out of the ground. The ugly part, the really bad part, is the pollution. So the pollution is quite dirty. Like we saw in the picture, it's really dirty, and it can create acid rain. And by acid rain, that's a rain that has excess carbon and hydrogen in the water. And then as it falls, it can hurt plants, it can hurt buildings, people, wildlife, the fish in the lakes. So it just causes the acidity to be off, and it can cause the water to be dangerous. Oil, the good, there's a lot of it. It's abundant. There's lots of it. It's easy to find. And there's 3 times the energy as wood. And then we're not going to put, so if you notice on mine, I did not put pipeline transport because now there's arguments that the pipeline transport is actually dangerous because they have to dig up the environment to put the pipeline in it. And then if it spills, problems. So we're going to leave pipeline transport out. The bad part, it takes years to form. So it takes a long time for it to form. Drilling for the oil can cause destruction to the habitat or the ecosystem that it's there. It will run out eventually. And then there's big environmental risks if oil spills. So if it spills, it can hurt the water, it can hurt the animals. It takes years for it to get truly cleaned up. So it can be quite dangerous again. Natural gas, there's a lot of it. Again, there's a lot of it. Easy to find. It burns clean, so when I do burn it to cook with it, it doesn't cause an odor. It doesn't hurt the environment of the house that it's being burnt in. There's 3 times the energy of wood. We're going to leave off pipeline transport. It takes millions, the bad part, takes millions of years to form. It can hurt the ecosystem trying to get it out, and then eventually it's going to run out. And then the ugly part is there is some pollution. So on mine I wrote air pollution, so the changing it from the gas that we pull out of the ground to the gas that you would use in your house are to that part is where the pollution comes in. And then the last part on there is the nuclear power. So the good part about nuclear is there's low amounts of CO2 in the atmosphere, so it doesn't impact the greenhouse gases as much. It can produce large amounts of energy. The bad part is if an accident and a spill happens, it's really dangerous. And then uranium and plutonium are going to run out. Let's keep this up. So it will run out again. And then the ugly part is the toxic waste that comes out of this is really bad for the environment. And it's radioactive for thousands of years after the fact. And then if there is a fallout, or if there is some kind of problem at the plant, it can be quite dangerous to the entire ecosystem and like worldwide ecosystem. So then let's look at the second page. So that should be everything. All the blanks on this page are done. So now let's look at this part. Our 5 alternatives to energy, non-renewable resources. So I'm not going to write these in. You're going to write these in, but they're going to go right here. So our wind, how it works. Wind, how it works. The wind is going to spin those blades to make electricity. Advantages, no emissions, low cost to build. These things are in the scheme of how much it costs to, how much energy we get out of them. It's very cheap to build them for the amount of energy we get. The disadvantages, it only works where the wind blows. So if I put it in a place where there's no wind, it's going to be useless. But if you go out to like El Paso, where it's really flat and there's lots of wind, that would be an advantage. So location would also be a disadvantage. Solar, how it works. The sun rays capture in the photoactive cells. Sun rays are captured in the cells. It's non-pollution, no pollution, and the sun is really abundant. It's not going to run out in our lifetime. Disadvantages, it's expensive, sorta. It's getting less expensive. And you need sunshine. So if I put it in a place where there's very little sun, like in Seattle, it's only going to work sometimes. So I have to put it where there's going to be lots of sun. In parts of the desert of Arizona and New Mexico, they have huge solar panel farms where they collect energy and they distribute it to the entire like sun belt, so to speak. So up through New Mexico, Arizona, Utah, even up into Montana. So they use that sun farm and they distribute energy out that way. Hydrothermal, sorry, hydropower. How it works, moving water turns those wheels. There's no emissions. It's super reliable, so there's no pollution from it. And we know the water is going to move because we build it so that gravity will do most of the work. The disadvantages is it can change the environment if we're not careful, and it's expensive to build. Geothermal. How it works, heat from deep inside escapes up. Advantages, little impact on the environment, and there's very little emissions. So it doesn't hurt the environment, and there's a little tiny bits of pollution that come out. Disadvantages, it's expensive to start, and it can't be everywhere. So it's expensive to start, and it can't be everywhere. Biomass, dead plants are burned. How it works, dead plants are burned. Advantages, it makes auto and diesel fuel. And then the disadvantages is there's going to be pollution in the transport cost. So how I move it can cause some kind of pollutions. And we're going to go on the other side, other half of that paper, and it's literally fill in the blank. So alternative energies rely on natural processes and can be used to produce energy. For the resource to be considered a green energy, it must be renewable and clean. So renewable energy can continuously available. I can use it again and again and again. I can use it again and again. Clean means that there are zero or few carbon emissions. So there's zero or few carbon emissions, or CO2, that come off of this product. So then we have this thing here, our renewable versus non-renewable energy. So our renewable is alternative. I'm just going to tell us what we can write, because it says also alternative. These are another option or alternative to non-renewables. These produce less waste. So we're going to shorthand this renewable bullet point. Alternative energies. They make less waste. Oh, this card I can't spell. It's replenished easily. And I can use it again and again. Our non-renewables. There's a fixed amount of them. So there's a fixed amount. It's a one and done use. Put that in our use. It's gonna run out. They can make pollutions. Last but not least, this is the outside of it. So you're gonna label our 5 alternative or renewable resources. So the first one, solar, biomass, geothermal, hydropower, and wind. And that's where we're going to stop.